Welcome to Kevin's Classroom, the mathematics section. Some of you might be doing physics and chemistry with me. If so, welcome to the maths. If not, welcome to the maths as well. The same rules apply. We're going to be going through this, or maybe I should use the maths to introduce the rules. Basically, the way to get the most value out of these sessions that we spend together is you'll look up on a section what you want and you'll watch the relevant videos. Please make sure that you've got obviously the stop-start button, but you need to have the pen and paper with you because it only helps if you take down. You have to learn to take notes. So by taking down the recipes that I'm going to give you, for example, how to factorize, recipes for multiplying trinomials, recipes for exponentials and exponential equations, they're all going to be recipes. It's step 1, step 2, step 3, step 4. So obviously the best way is to take them down off the video, not to wait for the video to end and then say, oh gee, I've got to watch it again, because that's an unnecessary expenditure. So in each and every one, it's a self-contained unit that you need to maximize the use of. And the only way, as I say, is work through it with me. They're normally 20, 25, some up to 30 minutes. However, it's intense focus and it is critical that we go through it together one-on-one, okay? This is the same format as I do it with the students who sit right here with me in this room. Right, so let's get started. First of all, we're going to be looking at Algebra 1. Okay, just a few little quick bits and pieces. They say to us things like this, okay? Write, okay, and I do my writing is not great, okay? Please forgive me for that. I will do my absolute best with this because I know my 5s and my 7s and my 3s, heck, it could be anybody's guess. Some people have even taken a 3 for an 8, all right? But let's see. They say write, and they normally give us a decimal like 2.535 in the form A over B. And then they say A and B are elements of Z. Okay, it is important to know what Z is as opposed to the others, okay? Right? They want it as Z is an integer, all right? That's the theory part at the beginning, all right? I'm not going to do that with you. I'm going to stick to actually solving problems, recognition, and applying recipes to them. This bit of theory, very critical that you know, especially the Z difference between real numbers and Z, okay? For those of you going to AP, you are going to start looking at complex or imaginary numbers, the square roots of -1 and things like that, okay? Right, so let's have a look. First of all, we want to change to a fraction. Change to a fraction. Okay, that's quite important. So let's recognize that 2.535 over 1 is the same as 25.5 or 25.35 over 10, which is the same as 253.5 over 100, which is 2535 over 1,000. Okay, there we are. Now that is A and B, isn't it? There you go. There's your A and there's your B, and they are both integers. Well, that's cool, except for one thing. Always look to simplify. Okay? Always look to simplify. You can see that 2535 ends in a 5, that ends in a 0, which means 5 divides into there. So we're going to then divide 5, divide top and bottom by 5. You're going to end up with 507 over 200. The favorite that they love for a 3-mark question, or maybe even a 4-mark, involves recurring decimals as a fraction. As a fraction, what does a fraction mean? A fraction, they mean A over B, A, B, element of, Z. Okay? Otherwise, it's not really a fraction, is it? 3.5 over 9.7 isn't a fraction. Okay, so what do we do? They say, let's first of all take 0.123. So let's say they've given us 0.123 and they've said dot dot, which means what? That is 0.123, 123, 123, 123 ad infinitum. It'll keep going, it's recurring. So what do we do here? Well, we recognize, we say, and the pattern's the same. We need to say that let's call this x. Let x be equal to 0.123, 123, and let's just put in the 123. Now change it until, let me use black. Make the next one, therefore 1000x is going to be equal to 123.123, 123, 123, isn't it? Okay, like that. I have moved the decimal place 10, 100,000 3 times, right? We've moved it 3 times. In other words, we've got 1,000. We've multiplied by 1,000. Then you subtract the larger one from the smaller one. In other words, if this was equation 2, that would be number 1. We say equation 2 minus equation 1. Right? We subtract them. Well, what is 1,000x minus x? What is this? 123.123.123.123 minus 0.123.123.123. Can you see? Look at this. The whole back piece is identical. So when I subtract, that whole element, everything behind the decimal is gone. It's been removed. So therefore I've got, that is going to be equal to 1, 2, 3. So I can say 999x is equal to 123. Okay? Therefore, x is going to be equal to 123 over 999. Right? Now I can look to simplify that. 3, 4, 6, yeah. So I can say, right, I can divide into there, and I can say that's going to be equal to 3 will go into that. How do you see if 3 goes in? Remember from last year, grade 9s? Remember what you had? You add them all up and see if that's divisible by 3. 3, 2, 1 is 6. Yes, it is. So it's 41 over, and that's 3, 3, 3. Okay? And no, that's not going to come down any further. Okay? So my answer is that is 41 over 333. Okay? Now what happens if they give us, and this is the kind of the things that they like, let us say they take us 2.355. All right? All right? Right? 2.355. Let's say they say, write 2.355 da da da. Okay, and they say recurring there. All right? And let's just keep that as a fraction. Okay. So let's have a look at this number. We want to manipulate it so that we can get a recurring decimal on its own. So what do we do here? Well, first of all, can you see that this is the same as 2 plus 0.3 plus 0.05555 blah blah blah, right? Can you see that? Do you remember when you split up numbers in grade 4? Okay, grade 4 and 5, you wrote them in hundreds, tens, thousands, and you added them. It's 2,000 plus a 300 plus a 2 plus a 5, 2 tens and a 5. This is where it comes back. So we split the number up into that. Okay, here's our recurring piece, 0.055. So this is 2.3 or 2,3 plus 0.055555. Now then we say, we've isolated the recurring one. Let x equal 0.055555, haven't we? Okay, so what do we do now? Well, we want to manipulate this so that we've got 5s there. In other words, we want to multiply this by 10. So that's going to be 10x is going to be equal to 0.55555, okay, so on and so on. What do? We take the big one minus the small one. So it's 10x minus x equals, what is 0.555 minus that? Look what happens here. Okay, I'll go back to red. Can you see? That all disappears, right? Ending up with 0.5. 0.5. All right? So what have we done? We have taken this 10x and we're left with 9x is equal to 0.5. Now let's just go a little up here. So therefore 9x is equal to a half. How do we do that? Get rid of it? We multiply through by 2. Right? So therefore 18x is equal to 1. Therefore x is equal to 1 over 18. My final answer is thus. Okay? This is going to be equal to, I should have changed that, so my final answer is 2.3555 recurring is equal to 2 plus 3 over 10, change it all, plus 1 over 18. Okay, that comes to 2 and 16 over 45. Okay, 2 and 16 over 45. So in these, and I'm not going to spend much time further on those because they're generally one question here and there. They're for those of you who want to get yourself up to the 80s, okay, by getting every mark you can. Essentially, you look for the recurring bit, you manipulate it. If it's got, here's a sort of a rule for you, okay? Let's just try and invent one, shall we? If it's got a recurring 1, you're going to multiply it by 10. If it's 0.51 recurring, can you see it's that? You're going to multiply by 100. If it is 0.515 recurring, you're going to multiply, okay? You're going to multiply by 1,000, okay? So if it's 1 recurring decimal, you multiply by 10. If it's 2 recurring, okay? So let's say it's 0.57 recurring, right? Then you'd remove that 0.5 plus 0.07 because now we've got the recurring and you multiply it by 10. Okay? If it is 0.12 recurring, you'd multiply by 100. If it is 0.123 recurring, you multiply by 1,000, right? And by 10,000 if it's 0.1234. I'm sure you can get the pattern. You see what I'm talking about there. Okay? Right, now let's go up into algebra, shall we? Okay, and for goodness sake, you know what? Everybody goes, they start quaking in their boots with algebra and things like that. There's a whole load of recipes here that we're going to be going through. Let's have a look. First of all, let's just define some terms, okay? It's important, okay, as is to lock that down. What is a polynomial? Okay? Polynomial has got many terms, okay? It's got many terms, hasn't it? So a polynomial is x to the 4th plus y to the 5th minus 5x plus 3y minus 7, okay? It's got 1, 2, 3, 4. There are 5 terms, correct? 5 terms here. 1, 2, 3, 4, 5. Okay? Each one is different. X to the 4th, there's no others. X to the 4th is a strawberry. Y to the 5th is a lemon. 5x is an apple. 3y is an orange. And 7 is a prune. Okay? They're all different. You can't add them together unless you knew what x and y are. Okay? In which case you just put them in. So a polynomial is more than one term. I'm just quickly recapping. A trinomial, oops, let me just put this, trinomial. A trinomial has got 3 terms. Usually a trinomial looks like ax squared plus bx plus c. A, b, and c are numbers. Okay, so it generally looks like that. It could be 1x squared plus 3x minus 5. Okay, All they are, I'm just showing you, that's a general form of a trinomial, also called a quadratic, many cases, right? If it's a power of 2, it's a quadratic. Binomial is 2 terms, okay? So binomial is equal to 2x minus 5. Okay. What is the order of it? Well, the order is the highest power. Okay, so the order here would be order 5. It's y to the 5th. It's an order 5 polynomial. Okay, like terms, we've discussed it. Okay, 3xy minus 5yx. Are they the same? Of course, yes. Why? What is not written between that 3x and y is 3 times x times y minus 5 times y times x. There's a multiplication sign in between. What does that mean we have to do? Quite simply, it means that you can make them whichever way, because 2 times 3 times 4 is the same as 4 times 2 times 3. You can put them whichever way you like. Okay? I think if we go back, was that not called the associative law or something? Okay? So it's the same. So they are like terms. So 3xy's, think of it, I've got 3 lemons. An xy is a lemon. I've got 3 of them. I subtract 5 and I get minus 2xy, or lemons. Okay? What is a constant term? Okay? What is the constant? The constant, we're recapping, is this minus 7. Okay? It's minus 7 over there. That is the constant term. Okay? Right? And lastly, the coefficient. Okay? What is the coefficient? What is the coefficient of x in that one up there? The coefficient is minus 5. Right? It's minus 5. Why minus 5? Because it's the number in front of the thing. What is the coefficient of y? Plus 3. What is the coefficient of y to the 5th? 1. So it's the number that appears in front of the variable. Please note that now in grade 10, that number could be a fraction as well. I can hear every single person I'm talking going, no, I hate fractions. Unfortunately, it plays a very big role in where we're going. But once again, actually, we're going to put a recipe forward where we get rid of fractions ASAP. Okay, I don't like them either. The reason is that they're a huge margin for error, all right? Errors creep in all over the place with fractions, don't they? So what have we got here? We've got those. Now let's have a look. We're going to do 4 things. We're going to multiply terms. We are going to divide terms. We're going to add, and yep, the other one is we're going to subtract terms. Okay, so we're going to manipulate terms because our whole thing is we're heading towards simplify, which means factorize. Simplify means cross out, get rid of, make it smaller. Okay, we're going to go to factorizing, crossing out, cross cancelling, simplifying, and then we're going to put it all equal to 0, and we're going to solve for x. Okay, that's what we did last year. That's what we do this year. I don't want to repeat the pattern, but that's what we're going to do next year as well. Okay, ad infinitum in algebra and trig as well. We're going to be doing the same thing. Okay, add, subtract. Well, let's have a look. Let's just take an example, right? Let's say we've got 2x, that's 2 times x, times 4x. Okay? First, this is what I want you to do always. When you're multiplying terms, do it in this order. Sign, number, variable. Okay? Sign, number, variable, SNV. Okay? Sign, number, variable. The sign here is a plus times a plus is a plus. 2 times 4 is the number is 8. X times x is x squared. Let's have a look at a different one. minus 2x times minus 4x. Minus times a minus is a plus. 2 times 4 is 8. X times x, x squared. Let's have a look at this one. Minus 2x times 4x. Minus times a plus is a minus. 2 times 4, 8. X times x, x squared. Okay? Remember, x times x is x squared. Okay? So, we're always going to take that process. Now, let's have a look at this. Right? 2x times 3x minus 1. Okay? What do we do here? Well, what did we say? First of all, we now go, I prefer you to do this, okay? You take your pen, I'm just going to use green, and you put the little bridges across, okay? The reason is this. I'm well aware it might look very childish, but let me tell you, when you've spent 2, 3, 4 minutes multiplying a whole load of nonsense out, and you've made a silly mistake, you're going to feel like a real nana at the end of the day. Because it's very difficult to keep track of all of these. You're going to be multiplying a binomial by a trinomial, right? You're going to have a complete load of terms there. Do them one by one and you won't make mistakes, right? These are the tips that I can give you. If you're going for A's or B's in this subject, this is where the mistakes occur, by not following these simple little steps and rules, okay? So we say, right, sign. Okay, let's go back to black. Okay, what is the sign? A plus times a plus is a plus. 2 times 3, 6. X times x, x squared. Plus times a minus is a minus. 2 times 1 is 2. X times, there's no x there, so it's x times 1 is an x. Okay? Let's have a look at this one now. Let's take it another step up. Right? You'll see the same pattern. Let's say we've got 2x plus 2, right? There, going and multiplying that by 3x minus 1. Right, we're multiplying our two brackets now. So I say, there's my first bridge, and there's my second bridges. I know you do things like FOIL and all that kind of stuff. That's cool, okay? FOIL is great, but put in the things, inners, outers, whichever you like. Put in the little bridges, okay? Because you follow them. So let's do the first one. So, okay, black. Here we go. It's a plus times a plus is a plus. 2 times a 3 is a 6. X times an x is an x squared. Right? Then I'm going on the next one. 2 times minus 1 is minus 2. X times x. Okay? Let's go underneath. Plus times a plus is a plus. 2 times 3 is 6x. Right? And lastly is plus 2 times a minus is a minus 2, right? Sign, number, variables, right? Now we group like terms, okay? Grouping like terms. I can only say to you what I'd say to my students here who sit with me here. When we're working through these, every single one of my students has got colored pencils, specifically for this, right? What they do is they now, colored pencils, whatever you like. You can even use a pen. But identify, say, right, here's a squiggle. Have I got any more squiggles? No. Here's circles. Do we have any more circles? Yes, there's an X and another X. And you are on your own over there, right? Identify the terms so that when you group them, you've grouped them in a very efficient pattern. A lot of this math, I call it my mathletes, okay? These are the things, it's time. It's like athletics. We're running a race. Unfortunately, time, we are going against the clock, so time is important. So what are we looking for? We're looking for the little tricks and techniques that can shave off seconds. Because, hey, if we can shave off a few seconds everywhere, right? There's some things in physics where I teach the kids, the students, to shave off like 4, 5, 6 minutes, okay? That's the way we want to do it. We're looking for time. So here, by doing that, we're very quickly identifying that we have got 6 6x squared is 6 apples. Minus 2 oranges plus 6 oranges is plus 4. There's my oranges, minus 2. Okay? And just for the record, that is a trinomial. Right? A trinomial. Right. Now moving along. Okay, minus x times minus y. All right. You'll see the bulk of what we're going to do here is going to be examples after examples after example. Minus x times minus y. Okay, sign first is plus. What's in front of this x? Okay. Can you see there's a 1 in front there? We just don't write it. I don't write 1 times x, I just write x, don't I? So what do I say? I say it's 1. So it's a minus times a minus is a plus. A 1 times a 1 is a 1. An x times a y is an xy. All right? Because I don't know what x and y are. If I knew that x was 2 and y was 3, I could say that's 1 times 2 times 3 is the answer 6. But I don't know what it is. So we just leave it. All right? Let's look at this one. All right? 2b, or not to be, okay? 2b minus a and minus b minus 2a. Okay? What is this? Well, now, what do I say we do? We put in our bridges, okay? So let's do it. Can you see there? Now let's multiply them out. Minus times a plus times a minus is a minus. 2 times, there's a 1 in front of that b. So it's going to be 2. b times b is b squared. 2, there's a plus times a minus is a minus. That's going to be 4, 2 times 2, b, a. Okay? The next one, minus times a minus, I'm doing the a and the b. The first one of the undergraduate, the under bridge now, is plus a, b. And a minus times a minus is a plus 2a squared. Okay? Now we have to group like terms. Okay? Now for those of you who want to do it with speed, okay, maybe you just have one. You say, okay, you are a b squareds, no more b squareds. Okay, here's an ab, ba, same thing, right? And you are on your own. Okay, so we've grouped our like terms now. No, let me just put it back to black. We've grouped our like terms. Okay, so what are we going to do? Basically, we're just going to say it's minus, well, I'll put it here, minus 2b squared minus 4aba and plus 1 is minus 3ab plus 2a squared. Okay, so you can see if you put in the actual brackets, follow the SNV, sign, number, variable, okay, group like terms. Okay, I know, I'm well aware it goes, it can go pear-shaped very often. Now let's just have a look at this. 2x minus 3y all squared. What does that mean? Okay. Well, first of all, what does x squared mean? It means that thing times itself. When I see those, no, I don't get all, oh, I know what it is, I can do it in my head. No, I don't. I say that that is 2x minus 3y times 2x minus 3y. So when you see an all squared in a bracket, split it into the two brackets and then multiply out using these little whatever you want to call them, bridges. Okay, there they go. Okay. So now I can multiply them out. Plus times plus, plus. 2 times 2, 4. X times x, x squared. Plus times a minus is a minus. 2 times 3 is 6. X times y, xy. Then we've got a minus times is a plus, 6. That's a yx, right? But it's the same thing, isn't it? Okay, then it's a plus 9y squared. Now we group like terms. You and you are the same, and you are different. So we've got 4x squared minus 12xy plus 9y squared. Why do we write it this way? Because generally we write x, y, and z, because x comes before y, comes before z. We generally do that. We also write it in descending powers. Okay, those are just the ways we do it. You know, it's like you either left-handed or right-handed. In maths, that's just one of the things we do. Otherwise, everybody's talking the same language, but it's all it's unnecessarily garbled and gobbledygook. Okay, I know I'm going over a little bit here, but just because this is the intro, let's have a look at the next one. All right, let's have a look here. This is now a minus b all squared, which is a minus b A plus B, right? Remember what I said? Oops, sorry, my bad. There we go. Okay. I split them and write them apart. Then I go and I put my little bridges in, okay? Whatever you want to call them, it doesn't matter. That is going to be A squared plus AB minus BA minus B squared, which is going to be, can you see the middle term cancels out there? And we end up with A squared minus B squared. Please note that one, okay? Please just note that that is going to look like that, right? Where's the mistake there? Were you following it? What did I do in here? Here it is. Look there, when I split it, I wrote A minus and A plus. Oh dear. Okay. Can you see? A, make sure you're staying with me and you're spotting them, okay? If I do, sometimes the errors get made anyway, but often I'll make an error like I do with my students, okay? Please make sure that you are with, so that you can say, whoa, whoa, whoa. Because that, just this short 25, 30-minute focus and the notes will stand a long way towards improving your speed. That is actually A minus B times A plus, because I'm thinking of the difference of two squares, which we'll get to now, A minus B, which is going to be A squared minus BA minus 2AB plus B squared. I still, however, this one here is important, that A squared minus B squared is the same thing as A minus B, A plus B, all right? The last one we're going to do in this topic here is I'm going to do a binomial times a trinomial. Look at the gemors or the mess that happens here, all right? X minus y, okay, into x squared plus 2xy minus y squared. And now you say, oh no, but unfortunately I know that it's a complete pain, but still, we have to get through this, okay? All I'm trying to do is I'm trying to show you the least pain method, okay? I am going way over time, but it's the least pain method. What do? X times x squared plus is plus x cubed. Plus times is a plus, 1 times 2 is a 2, x times x is x squared, and the y stays because there's no y there, okay? And lastly, it's a minus x y squared. Okay, happy with that? Then I go to the next one and I say minus times that is a minus y x squared. Okay, minus times a plus is a minus 2x y squared. I'm multiplying this one and this one now, right? Minus 2x times 1, y times y is x squared. Minus times a minus for the last ones. Okay, the minus y and the minus y squared, we are on this bracket now. So we say that is plus y times y squared is y cubed. Why? Well, it's y times y squared, which is y times y times y, which is y to the power of 3. Now we group like terms. Let's have a look here. Let's see. X squared y's, I've got no more x. I know I've got no more x cubes. Okay, so you're done. X squared y's, there we go. There's another one. Okay, now I'm going to go over to green. Xy squared, there's another xy squared. And y cubes, I know I've got a u on its own. So I group the like terms and I say that is x cubed plus 2x squared y minus one of them is plus x squared y, right? 2x squared y minus 1x squared y is that. Minus xy squared minus 2 of them is minus 3xy squared plus y cubed. That there is the answer to that one. Okay. We're now going to start with the factorization in the next session. That one was way over time. It's probably the longest video recording I've ever done. But I wanted to get through that section, so please forgive me. I'm going to end off very rapidly. Thanks for watching. Let's get into some factorization next, and we'll then start looking at exponents and equations and stuff. Now I'm going to stop talking. Cheers. See you later.